I am Krishnaveni. I am working as assistant professor in AC department, KIT Kalayan Karunanidhi Institute of Technology. Now I am going to talk about pulse modulation and their types and PCM. First we see about the introduction of pulse modulation. Many signals in modern communication systems are digital, also analog signals are also transmitted digitally. For reducing distortion and improvement in SNR ratio, we are using the digital transmission. PAM, PWM, PPM, PCM and DM are some of the digital and pulse modulation techniques. PM is called as the pulse amplitude modulation, PWM is called as the pulse width modulation, PPM is called as the pulse position modulation. These three types of pulse modulation, we are using the input is the sine wave and carrier is the pulse, it may be square wave. Data transmission, digital transmission or digital communication is the physical transfer of data over a point to point or point to multi-point communication channel. Example, optical fibers, wireless channels, computer buses. Now I am going to discuss about the types of modulation. There are two types of modulation, continuous wave modulation and pulse modulation. In continuous wave modulation, we have two types, amplitude modulation and angle modulation. Again, amplitude modulation subdivided into four types, that is DSPSC, AM, DSBF, FCAM, SSBSC, AM and VSBAM. Angle modulation consists of two types, frequency modulation and phase modulation. There are two types in frequency modulation, wideband FM and narrowband FM. Now see the pulse modulation. There are two types, analog modulation, digital modulation. In analog modulation, input is sine wave, carrier is pulse wave. In digital modulation, input is pulse and carrier is sine wave. There are three types in analog modulation, PAM, PWM, PPM. Already we discussed these three types. Digital modulation, there are two types, pulse code modulation, delta modulation and then so on. Analog pulse modulation. Analog pulse modulation results when some of the attributes of the pulse varies continuously in 1-to-1 corresponding with the sample value. Some of the parameters are pulse width, pulse amplitude and pulse position. In analog pulse modulation system, the amplitude, width and position of the pulse can vary over the continuous range in accordance with the message signal. It is the sine wave. There are three types, PAM, PWM and PPM. In PAM, high frequency carrier is varied in accordance with the sampled value of message signal. PWM, in this width of the carrier pulse is varied according with the message signal. Example, speed control of DC motor. PPM, in this PPM the pulse position is varied accordance with the sampling signal. This is the waveforms of the pulse modulation. First one is the message signal, second one is the pulse amplitude signal. The amplitude of the pulse is varied in the both negative and positive half cycle. PWM, width of the each pulse is varied as shown in the figure. Pulse position of the each pulse is varied according to the message signal. Digital pulse modulation. In this system, digital pulse modulation, the transmitted sample take only one discrete values. Two different types of digital modulations are delta modulation, pulse code modulation. They are producing the output as the zeros and ones. 0 means off, 1 means on condition. This system provides the continuous zeros and ones. PCM is called as the pulse code modulation. It is a digital modulation technique. Here a special form of ADD conversion takes place. It consists of the sampling, quantizing, encoding. Sampling is the process by which sample of the signals are taken in continuous manner. Quantization is the process by which the sampled signals are quantized to the nearby value. It is called the round offing to the nearby value. This is a block diagram of the PCM. In the transmitter side, PAM signal, quantization and encoding. ABC are called the pulses. The value of voltages are 3.8, 1.2, 5.7. The 3.8 is the sampled value. It is rounded to the nearest value 4. It is called the quantized value. Encoded value means it is the zeros and ones value. For binary value, for quantized value 4 is 100. B is the pulse. It has the voltage 1.2. It is rounded to the nearby value 1. It is called quantization. The binary value is coded as 001. Similarly, C is the another pulse. This is the sampled signal from the continuous wave. 5.7 is the value. It is quantized to 6. It has the binary value 110. It is the PAM plus quantization and coding technique. It is called the PCM transmitter. As shown in the figure, the input is analog signal or continuous signal. It is mingled with the sampling pulse in the PAM. We get the discrete signal at the output side, and then it is quantized to the nearest value or round off to the nearest value, and then it is converted. Discrete value is converted into the digital value. So the digital value is called the discrete value and discrete in time signal. It is the encoded signal for the quantized pulses A, B, C. The value is 1, 0, 0. It is first one on, so 2 on, 0, 0 is the off condition. B pulse 0, 0 is the off condition, 1 is the on condition. For 1, 1, 0, both 1, 1 is the on condition, 0 is the off condition. It is the encoded signal for the quantized pulses. Due to the noise, the pulse shape is varied as shown in the figure. Received pulse is like some noise. It is some like analog signal form. So during transmission of the signal in the air medium, the noise will be added. So we get the received signal as the noise and original signal. So it is the PCM transmitter and receiver. PCM transmitter consists of sampler, quantizer, encoder. The corresponding waveforms are as shown in the figure. Receiver consists of quantizer, decoder and holding circuit. The output of the low pass filter is the original analog signal. The noise signal is transmitted to the receiver through the medium. The transmitted signal it has a noise, so it will be removed in the filters in the receiver side, and then we will decode the binary signal into some decimal value, and then we convert the decimal value into some waveform using the low pass filter as shown in the figure. It is the main block diagram of the PCM system. The regenerative repeaters are used in the transmission medium to avoid the noises. These are fixed at the equal interval in the overall distance in the air medium. These are some of the basic elements of the PCM. Low pass filter, sampler, quantizer. Low pass filter is used to tune the frequency some value. It only allow the frequency of the range of signal, omit the unwanted signals. Sampler, it converts the continuous signal into discrete signal. Quantizer is the process of reducing the excessive bits and confirming the data. So it is called the nearest value of the sampled signal. Encoder converts the sampled value and quantized value into original binary signal. Regenerative repeaters consist of the following circuits: equalizing, timing circuit, decision making device. It is used to reduce the distortion and noise in the medium and the receiver. It is the regenerative repeater circuit. Distorted PCM signal is given to the equalizer and timing circuit and decision making device. We get the regenerated PCM pulse signal. So noise is added in the transmission medium. So we will avoid the noise using the regenerative repeaters. These are fixed at the equal distance in the air medium. Decoder decodes the waveforms into some digital bits. So here converts the zeros and ones into some sampled value. reconstruction filter. All coded words are passed through the low pass filter so that analog signal is output. This is a PCM waveform. This is zeros and ones. As shown in the figure, we get the zeros and ones. These are decoded using the decoder, and then we get the low frequency modulating signal. Thank you.